Okay, and this next thing, what we're going to do is find partial derivatives. Okay, now our partial derivatives are denoted with this subscript, like f subscript x of x comma y. What that means is we're still taking the derivative like we had like f prime, but we're taking it with one of the variables considered as a constant and the other one considered as a variable. In this case, the partial derivative with respect to x is to treat x as a variable and treat y, the other variable, as a constant, just like a number like 4 or 5 or 10. So let's look up above at what we're trying to take the derivative of. F of x comma y, we got 9x to the third plus 4x squared y plus 13y squared. Now x is the variable. Everything else we treat like a constant, okay? So if we take the derivative first for 9x to the third, same derivative rule applies that we normally would. 3 times 9 is 27. Take one away and get x squared. Nothing really different there. Next one over, we'll have 8x with a y still sitting next to it. The reason why the y stays there is it's a constant, so we don't have to do really anything with it. It stays there like the 4 would have stayed out in front to get multiplied by 8. So 8xy is what we get from there. Now the last term, though, doesn't have an x with it. This whole term, we treat this as entirely a constant here. So its derivative is just 0. So the result here is just 27x squared plus 8xy. Now when we look at the f subscript y, so this would be the partial derivative with respect to y, we're going to treat y as the variable now and x as the constant. And if we do that here, let's look at the terms. Well, look at how the first term has just x in it, no y involved. Now we're going to treat this whole thing as a constant. So in the derivative, we're going to write a 0 here for that whole term. Plus, this will be next term. When we take the derivative here, it's going to just be 4x squared. The reason why it's just 4x squared is because, again, y is the variable, and when we take the derivative of just y, it goes away, leaving just the stuff next to it in the front. So it'll be the 4x squared here in this case. Plus, and then the last term, same trick to find the derivative here. 2 multiplies times the 13, take one away, you get 26y. So this one would be 4x squared plus 26y. On this next one, it says a firm produces 2 types of calculators each week of type A, X of type A, I should say, and Y of type B. There's revenue and cost functions listed below. These revenue and cost functions use both X and Y because, again, there are 2 different types of things at work here, 2 different variables. It wants us to find this P and then the partial derivative P of X and the partial derivative P of Y, and interpret the results. Now, what they mean by capital P is profit. So just like we've done with profit before, we have to take revenue minus costs. So what that was going to look like here is we have to take everything from revenue. I'll write that down here. 210x plus 110y plus 0.05xy minus 0.07x squared minus 0.03y squared minus 9x plus 3y plus 30,000. Okay, and if we subtract everything in the common like terms and all that stuff here, if there are any, And what we're going to get here is this 210x and 110y. Those are like terms. So we can write this as 201x plus 107y after subtracting away the numbers, plus 0.05xy minus 0.07x squared minus 0.03 y squared minus 30,000. This is the profit function when it's all put together here. What it wants us to do with this is to find, first off, the partial derivative, or just do the partial derivative without any numbers plugged in here. This is partial derivative with respect to x, so x is the variable and y is the constant. Looking through our function above, that would look like 201 plus 0 plus 0.05y minus 0.14x minus 0 minus 0. Again, y is a constant, x is a variable, so when we go through and take the derivative, it should look something like this. Now, if we go through here and we plug in 2100 for x and 1100 for y, it's going to look something like this. That all it will be equal to negative 38. Now, how do we interpret this number? Because it also wants us to do that here. That means that profit is declining by $38 as the value of x increases. Now, the reason why I'm singling out the x is because we're taking the derivative with respect to x. Y is constant. So as x changes, this is how the profits will change. Now, let's go ahead and do the partial derivative. Keep that on the screen here so we can see it with respect to y now instead of x. Let's see what that looks like. It's going to look like 0 plus 107 plus 0.05x minus 0 minus 0.06y minus 0. Again, I'm highlighting the zeros where they're nothing but constants. Here, y is the variable, x is the constant. Now, if we plug in here the same numbers we just did, it's going to look like 107 plus 0.05 times 2100 minus 0.06 times 1100. Okay, see what that's equal to here. This is going to be equal to 146. So what that means for us here in the context of this particular situation is that profit is increasing by $146 as y increases.